Good morning. Today we are going to be covering solving absolute value equations. And this is going to go with worksheet 110. And today's date is October 20th. Okay. So as a quick reminder, absolute value means that we are looking at the distance from zero. So anytime we have absolute value, we're essentially looking at distance, and therefore it always must be positive. So in an absolute value equation, it's very similar to how we solve a standard equation. You're going to be given an equation. Because absolute value has to turn into a positive, we essentially have two possibilities. Inside this absolute value could be 6, positive 6, which would equal 6, or negative 6, which after taking the absolute value would still be positive 6. So what we do is we take what's inside our absolute value and we write two equations. One set equal to a positive and one set equal to a negative. Now at this point, we just go about solving like we would solve a regular equation. So this is a plus 4, and then x equals 10. And then over here, I would say plus 4, and x equals negative 2. And then from there, we are going to do a check to make sure that our solution holds true. When we are checking, you want to make sure you go back and you check within the original equation, not something that you have manipulated. So here's my original equation. I'm going to substitute 10 for x. This is now the absolute value of 6 equals 6, and 6 is 6. So that worked out. And then over here, I'm going to take the same equation, and I'm going to substitute negative 2 for x. So I have negative 2 minus 4, absolute value equals 6. This becomes the absolute value of negative 6 equals 6. Remember, absolute value is the distance from 0. So this is 6 away from 0. So 6 is 6. That's true. So that's what we are going to look at when we are solving our absolute value. Now what we're going to do is look at an absolute value problem that is not a standalone, meaning the absolute value is not isolated. So this is going to be my example 2. And I have here the absolute value of 3x plus 9 minus 10 equals negative 4. So when we are solving absolute value equations, the first thing I need to do is isolate my absolute value. So in this case, my absolute value is not isolated due to the fact that this 10 is here. So I need to get rid of this 10 by moving it to the other side. So the first thing I'm going to do is I'm going to add 10 to both sides. I now have the absolute value of 3x plus 9 is equal to 6. From here, I now write my two equations. So one being positive, 3x plus 9 equals 6, and one being negative, 3x plus 9 equals negative 6. Over here, go about solving regularly, so subtract 9 from both sides. 3x equals negative 3, divide by 3, divide by 3. X equals negative 1. Over here, minus 9, 3x equals negative 15, divide by 3, divide by 3. X equals negative 5. And then again, we're going to do a check. And so when we do this check, what we're going to do is go about substituting back into the original. So I have the absolute value of 3x plus 9 minus 10 equals negative 4. So I'm substituting negative 1 for x. So the absolute value of 3 times negative 1 plus 9 minus 10 equals negative 4. At this point, I have negative 3 plus 9 minus 10 equals negative 4. This here becomes the absolute value of 6 minus 10 equals negative 4. So 6 minus 10 equals negative 4. Negative 4 is negative 4. So that worked out. And then I have another one over here. This one over here is going to be the absolute value of 3x plus 9 minus 10 equals negative 4. This is the absolute value of 3. I'm going to substitute in my negative 5 plus 9 minus 10 equals negative 4. This is now negative 15 plus 9 minus 10 equals negative 4. This is the absolute value of negative 6 minus 10 equals negative 4. So this is 6 minus 10 equals negative 4. Negative 4 equals negative 4. So that is correct. On this next problem, we have a double absolute value. So this is example 3. So in example 3, I have here 3x minus 4, the absolute value of 3x minus 4 equals the absolute value of x. So essentially, when I have a double absolute value, I need to just make sure that one of my absolute values is isolated. In this case, they both are isolated, but I'm going to choose this to be my isolated one, just because that's following the pattern that we've seen in the last couple problems. So I'm going to do the exact same thing. I'm going to take this out of my absolute value, and I'm going to set it equal to a positive and a negative one of these. So I have here 3x minus 4 equals x, and I have 3x minus 4 equals negative x. So on this problem here, I have minus x. I'm going to get all my variables on one side. I have 2x minus 4 equals 0. I'm going to isolate my x, so I'm going to add 4 to both sides. I have 2x equals 4. Divide by 2, x equals 2. On this side over here, same thing. So I'm going to add x to both sides. In order to get my variable on one side, I now have 4x minus 4 equals 0. I'm going to try to isolate my x. So I have 4x equals 4. Divide by 4, x equals 1. And then I am going to go ahead and check these. So again, on my check, I'm going to use my original equation to make sure. So this is the absolute value of 3, substitute in 2, minus 4 equals the absolute value of 2. So this here is 6 minus 4, absolute value equals absolute value of 2. This is the absolute value of 2 is the absolute value of 2. That works. Over here, I have 3x minus 4 absolute value equals the absolute value of x. So here I have 3, substitute in 1, minus 4 equals the absolute value of 1. This is now 3 minus 4, absolute value is equal to the absolute value of 1. This is the absolute value of negative 1 equals the absolute value of 1. That would become 1 equals 1. And that is true. Okay, that we have one more example here, and I believe that's example 4. Okay, so in example 4, I have the absolute value of x minus 2 is equal to 4x plus 8. So on this side here, my absolute value is already isolated. So I'm going to set this side equal to a positive and a negative. x minus 2 equals 4x plus 8. And then I also am going to have x minus 2 equals -1 times the quantity of 4x plus 8. So this is setting that side equal to a negative. Going back to this side, I'm going to go ahead and get all my x's onto one side. So I'm going to subtract x. I have -2 equals 3x plus 8. I'm going to subtract 8. I'm going to subtract 8. This is a zero pair. I get -10 is equal to 3x. Divide by 3, divide by 3. X equals -10 thirds. On this side over here, I have x minus 2 equals -4x minus 8. Getting my x's all to one side, so I'm going to add 4x to both sides. I now have 5x minus 2 equals -8. I'm going to add 2 to both sides. I get 5x equals -6. Divide by 5, divide by 5. X equals -6 fifths. So there are my two solutions, and then we do a check. So on my check, again, I'm going to substitute back into the original problem, which is the absolute value of -2. I'm sorry, x minus 2 equals 4x plus 8. I'm going to substitute in -10 thirds for x. So this is a -10 thirds minus 2 equals -10 thirds times 4. I did that backwards. Sorry, I had already started writing. Plus 8. So on this side, I'm going to work through this. This is the absolute value of -10 thirds minus 6 thirds, which is equal here to -40 thirds, plus this would then be 24 thirds. So this is the absolute value of -16 thirds is equal to, here is -16 thirds. Let me adjust my camera there. So when I take the absolute value, distance from 0, so it turns everything into a positive. So I get 16 thirds is equal to -16 thirds. That is not a true statement. So what we have discovered here is that this is actually not a solution. This is a special case. This is what we call an extraneous solution. And that is something that can only happen when we are solving absolute values. So an extraneous solution this is a solution that emerges from the process of solving the problem, but is not a valid solution to the problem. So essentially, what an extraneous solution is I'm going to solve. I'm going to get an answer. Your answer seems like it's correct because you got to it by doing the correct math. Then I go back and I check. When I do my check does not hold true. That is because it's an extraneous solution. I can only determine if it's this type of solution if I check my work, which in this case is super important for our absolute value situations absolute value equations because this is the time that these special case solutions pop up. So if I am doing my math and at the end I get an untrue statement in my check, that is no longer a viable solution. That is an extraneous solution, and it is no longer an answer to the problem. So now we need to check the other side to see if that one holds true. In this case, I have here the absolute value of negative 6/5 minus 2 equals 4 times negative 6/5 plus 8. So this is the absolute value of negative 6/5 minus 10/5 equals negative 40/5. Nope. Got excited. 4 times negative 6 is negative 24/5 plus 40/5. This is now the absolute value of negative 16/5 equals positive 16/5. So absolute value distance from 0 must be a positive. 16/5 is equal to 16/5. That is true. So my absolute value equation went from having two solutions to only one solution. When we have situations like this, it is important that you write down next to the answer that is extraneous, that it is an extraneous solution. I need to see that you know. I also need to see that in your check, it's not equal. If you leave it set equal, then there's confusion as to whether or not you know what is actually true or not true. So there you have it. That is the intro lesson to absolute value equations. And I hope you have a great day.